Hello everyone, this is project presentation by Team 42. Team members are Abhinav Chauhan, Shilpak Dev and Udit Kumar Jain. So our project topic is variation performance of bowling style based on weather and pitch condition, in which we are predicting the best bowler with the approximation measure of run conceded by that bowler for that particular over. So here's the introduction. Like we are implementing this on a T20 cricket on IPL tournament. So basically, our focus is predicting the run conceded by the bowler types, and for this we have considered only six bowlers. Uh, so six bowlers consist of left arm spin pace and medium pace, and right arm spin pace and medium pace. So goal is basically to build a context-aware model which predict the decision by taking input of various features like weather, soil condition, and various other parameters like the run considered uh, by that bowler type for that particular venue, or the in that particular the bowling phase like the death over or the power play. So the basically the problem statement is challenging, selecting the optimal bowler type to minimize the run in T20 matches. So current practice like usually the this prediction is based on the intuition by the coaches. Our objective is to use the data set and use those data set for the prediction of those bowler types. So basically, uh, these are valuable. So our model will be valuable for condition like coaches, analyst, fantasy platform, and broadcaster. And it can also act as a data-driven captaincy because you can predict bowler going to concede the less number of run for that particular over condition. And basically, the novelty of this project is that our model is a context condition aware model. Basically, generally the model uh, use only the averages and the match stat, but our model not only use those features, it also incorporate dynamic features such as the bowler venue condition for from that historical data to that particular point, and the phase wise average it has considered run from death overs, middle overs, and power play.
Basically, we have taken two dynamic features. One is bowler venue economy and another is bowler phase economy. So by phase we means that power play 1, 2 and 3. Like batters will hit more in power play 3 as it is near to ending of the match, and so it is a critical feature that we are having in to train our model.
And it also has an impact on sport industry, like it can help the fantasy league cricket platform for predicting the match performance, and it can also be used by the talent scouting teams for like scout can understand a bowler true value adjusting for condition, like spinner performing well on flat track is more valuable than one thriving only on turning pitches. So our basically the most challenging part is for the data extract part. All the sites have basically the data which have only ball by ball values of the run conceded and the wicket taken, but it doesn't have the values of various weather condition, soil condition, and and the dynamic feature we are talking about, like the
That bowler phase and venue phase economy.
yeah value phase economy. So how these we collected, like from basic data set we have collected from the quick sheet site, and for the weather condition we use an API called OpenMeteo, which use
Basically, if a match happened on, let's say, an X date, we use an API to collect the weather of that X date and integrate it with our data set.
yeah. And for the bowling style, we have used a Kaggle dataset from that where we got the match the bowler name with that particular bowling style, and our total data set is 31,000 plus entries over entries. So during the data analysis, we found these data points like spin bowler are most economical in middle overs, like they are considering 6-7 runs per over if the it's in middle of the over, and fast bowler are struggling in power play and death overs. And second feature is like left arm bowlers are concede less runs as compared to the right arm bowler. So methodology is pre-processing. We are using this encoding like venue, soil type, match phase, temperature, humidity, wind speed, and temporal feature we are using are economic rates computed up to that match dates, and for scaling we are using standardized numerical methods. Okay, so for the model
Training
first,
purpose, we are using two models.
yeah,
One is random forest and second is transformer
yeah.
model.
So for the random forest, we selected because it's handled tabular data well and it's interpretable and robust to noise. But when we train on it, it's gave a accuracy of around 27%. And I think it struggled with the non-linear interaction and class imbalance. Maybe that is the reason for such low accuracy. And the second one is for we used our transformers. Basically, they are complex, better to capture complex pattern, better attention mechanism, and they're better in handling class imbalance. But they still also achieve only 34% accuracy. But it's a significant improvement of 7.2% compared to the random forest
Yeah.
part.
Let's go ahead with the demo part.
Yeah.
So here we have our trend model already. So let's make a prediction on over number, let's say 7, just after the power play 1, and see what is the result. So at temperature 32.5 and other weather conditions at Wankhede Stadium, the model predicted that over number 7 should be bowled by the bowler right arm spin, bowler of type right arm spin, and expected runs that he will get in that over is 7.55. And along with this, our model is also predicting.
The next best bowler you can select apart from right arm spin.
Yeah, the
Here is a
next.
percentage according to which you can select the model with the highest percentage.
So it would be very much valuable for the coaches to select the bowler based on these dynamic conditions and previous
and
conditions.
the result are basically good one because you can see like right arm spin conceding only 7.5 run
Hmm.
in the over number 7, as we have seen from the data analytics part, like the
Yeah,
in the middle over the spinners are
doing
better,
well.
doing well
Hmm.
compared to the
So
fast arm bowlers.
it is telling like our model is behaving good. Let's see on over number 19, the most valuable over of the match, that is death over. For model over number 19, our model predicted a bowler type of right arm fast, and expected runs to be considered in that over would be 8.47, which is indeed correct. As we have seen in many matches, the death overs are only bowled by the fast bowlers.
And also you can see like here the values of the spin bowler like left
It
arm
is very
spin and
less,
right arm spin selection are very less, meaning they are worst performance for this over.
and our model is doing good.
And these are the parameter we are taking: temperature, humidity, precipitation, wind speed, venue, soil type, and cloud cover and over
And,
number. These value you can change.
and basically, these dynamic parameters are calculated currently using the dataset only.
And so like we can also show for another stadium, like you can change this.
Yeah,
uh,
fix. Yeah, we can do it. Like currently, we do not have a name. Let's see in final.csv. So let's say that's Arun Jaitley Stadium. AR Stadium.
yeah, now we can run it. Yeah, so
So
here the best bowler still we're getting.
is right arm
It's
fast
right arm
only,
fast
and
only.
expected runs
Yeah,
increased based on the model parameters.
8.63. For the previous one, it was 8.55.
8.5. And
Thanks.
if you see that Arun Jaitley Stadium is little less in area as compared to
Wankhede Stadium.
Wankhede Stadium.
So
So,
it's
so
going
its
to get
bowling
more.
averages are more as compared to Wankhede.
Thank you. Here we conclude our presentation
Here we
part.
can conclude our presentation with a lasting.
Conclusion, like transformer are outperforming the random forest, and strength are we are using capturing waves pattern from
So
the
basically,
weather condition to
we
which
transition from random forest to transformer because we are having imbalanced data. Still, we are having 34.31% accuracy. Just it is less just because we are having we are limited by data set because we are having imbalanced bowler type data. We have far better data of right arm pacers as compared to left arm spinners. So it is affecting our model. It might we can say that our model gets overfit on right arm pacers, but it is still what we can do in this case.
In future work, like we can use data augmentation, player specific feature, and multitask prediction. We can also include in it. Here, thank you, and we
Thank you,
conclude our
everyone.
presentation.